Hello, everyone. So thank you so much for being here. It's also good to be back to Zurich. The last time that I was here was, of course, 2018. And today we'll talk about Istio and as a service mesh implementation for our microservice. Okay. By the way, most people always ask me about the slides. Can you share your slides? And usually I say, okay, that's fine. You can get it now. The slides are available in this URL, bit.ly/istio-kubernetes. So you can go to the links and keep the link for you, because usually I'm always updating the slides. So it's a way to always get the latest version of everything. My name is Rafael Benevides. I work for Red Hat as a Director of Developer Experience. This year, I will complete 10 years of Red Hat. So it's a long journey, many different projects worldwide, traveling worldwide, talking to customers. And of course, one of the good things is that I can always come to community events just like this and bring the coolest things that I've saw and solutions that we are sharing with customers worldwide. And one thing that I like to share with you before starting talk about Istio is about the Red Hat Developers Program. There you can find resources for developers. For example, these free ebooks. You can just go to these links here. You can download Microservice for Java developers for free, building reactive microservice in Java, migrating microservice database, introducing Istio service mesh for microservices. By the way, how many Java developers do we have here? Woohoo! That's great, everyone. Yeah. It's good because I cannot forget to mention about the microprofile I/O and also the specification to build microservice in Java. And plus, have you heard about the announcement of Quarkus I/O last week? Woo! So for those who haven't seen Quarkus, let me just give you a brief overview of Quarkus. So let me just open a new window here, increase the font size, go to my downloads page, and use a Maven plugin to create a project. I'll just use this. con.rafabene, hello world, everything lowercase, hello world, and the path will be hello. So that will create a Quarkus project that I can perform a regular Maven package. Nothing new, nothing special until here, but when you have the jar file, just like I have it now, I can perform a java-jar using the fat jar here, and look, it started in less than 1 second. And plus, yeah, that's amazing. Let me look for Java projects here. Less than 100 memory, 100 megs of memory. And if I open the page, here I have a complete application that can use JAX-RS and everything related to microprofile and other cool projects as well. So I can go also to hello. I have a JAX-RS endpoint. So yeah, it's really fast and cool. Okay, but let's talk about Istio, the purpose of this presentation. Of course, when we decided to create microservice, we need to go through a kind of evolutionary process, right? So before having our first microservice, we need to make our team or teams, different teams, to adopt DevOps practices, right? Then with DevOps practices, we can also think about elastic infrastructure on the cloud. Usually in the cloud. Can be a private cloud, a public cloud, but something that you can shrink or grow depending of the demand of that service. Then you can have, you need to have an automation, build automation, installation of environments using tools like Chef, Puppet, Ansible. With automation, you can think about also a CI/CD pipeline. With a CI/CD pipeline, you will have advanced deployment techniques. Then you can have your first microservice, become the next Silicon Valley unicorn. But if you think about Kubernetes, OpenShift, and Istio, you will have a lot of unicorn love from these tools related to self-service on-demand, elastic infrastructure, automation, CI/CD deployment pipeline, and advanced deployment techniques. But before starting producing microservice, we produced monolithic applications for many years, right? And everything, those monoliths, of course, it was not just a huge block. We had modules. But in a moment in time, I will talk more about the history of microservice in a bit. We decided to use and produce microservices, right? But of course, all these microservices here, they are not inside a single server. We spread them on different servers or different nodes, and we create a network of service mesh, a network of service and service mesh. Of course, each microservice can have their own data. Most of the time, if we have 100 microservices, probably we will have 100 databases. Some of them can have different points of entry. And when we are talking about microservices, in fact, we are talking about distributed computing. And every time that we think about distributed computing, it's easy to think that the network is always reliable. We never thought about that when we had just a single server. We never thought that the latency could be a problem, because when you have everything in a single block, you don't have latency, right? So we tend to forget about the latency, we tend to forget about the bandwidth, we tend to think that the topology does not change. So there are a lot of fallacies about distributed computing. So when you have a failure on a service, what you don't want is a cascading failure. You want to avoid that. And to avoid that, usually you bring some capacity, some properties to your microservice. So inside a microservice A, that we'll call microservice B and C, usually you end discovery. Okay, you need to find the microservice A needs to find microservice B. You need a load balancer because you can have multiple replicas of the microservice B and C that you need to access. You need to think and provide resilience because the service B will fail. The difference when in our mindsets when we are thinking about microservice is not that it can fail, but it will fail for sure. We are talking about distributed computing. We saw the fallacies. So there could be a lot of network issues. So it will fail. We need metrics, we need tracing. And for many years, to achieve those capabilities, we placed them inside our application using libraries. So let's recap the history of microservices. Most of us saw that in 2006, the cloud was born. Then there was the era of the fat jars. It's good that I'm here with a lot of Java developers, so we know that what are fat jars. We know that what we are talking about when we mention Drop Wizard and Vertex from 2011. Then Netflix went open source in 2012. And finally, in 2014, 2013, with Spring Boot, containers, Docker, Kubernetes, and the microservices have been defined by ThoughtWorks, we had the perfect storm to produce microservices. Of course, there are several principles when we are talking about microservice. We don't produce microservices because it's cool. That's not a reason enough to use microservice, because to produce microservice, it's hard to produce, it's hard to deploy, it's hard to maintain. So the only reason that we produce microservices is because when we have deployment independency, we can achieve agility. Because one team is not tied to another, we don't need to refactor the whole system, we can deploy just a part of a specific microservice using a technology that will fulfill all the business capacity or the business logic or the business use case that you defined. So yeah, microservices are around business capabilities. It's not about the technology itself. Because we are talking about distributed communication and distributed components, distributed computing, the focus on the API needs to be very clear. But where the idea is, you have a well-defined API, but and you evolve your implementation. But of course, the API can change, so you need evolutionary design. I talked about the design for failure, so we have some principles. But returning to Netflix OSS, we produced microservices placing libraries inside our Java code. Usually when I go to conferences, it's not like here where we have a lot of cool Java developers, but we have also cool kids on the block producing microservices with Node.js, Go, Python, right? And for them, they don't use Netflix OSS. They need to find a library that fulfill load balancer, resilience, circuit breaker, and different capacities for their code. So, no matter if you are producing a microservice using Java, using Go, using Node/JavaScript, or if you are using Java with Vertex or Spring Boot, you need to provide all those properties, all those capabilities for your microservice. The first one is very clear, right? You need a very well-defined API. But it's not only about the API. You need to make yourself available. We need to find that microservice to be called. We need a discovery service. Then that microservice needs also to be invoked. So we need to provide an invocation. It could be a REST endpoint, it could be messaging. We need to provide elasticity because that microservice can be more accessed. So we need to grow the number of replicas or shrink if it's not being used. We need a resilience because the other microservice or the microservice itself can fail. We need a way to get that code and take it to production, right? And for that, we'll not just send a jar file by email, right? We'll use a pipeline. Some microservices can have authentication. Some can they might need authentication and authorization. We need to provide a logging, but not just a single logging, a distributed logging, because we are talking about distributed computing, different replicas running. The same thing is for monitoring and tracing. When we have a single block, a monolithic application, we have a single stack trace, which makes it easier to debug. But for distributed computing, we need distributed tracing. But the good thing is that, as I said in the beginning, if you use Kubernetes plus OpenShift, you will have most of those things for free. So for example, if you take your Java application and place it inside Kubernetes, you will have discovery for free. So you don't need Eureka or Ribbon. You will have invocation for free. You have elasticity for free. Plus, OpenShift, because OpenShift provides pipeline, you will have pipeline, you will have logging, you will have monitoring. Now, I'd like to talk to you about Istio. Istio is an implementation of Service Mesh, and Service Mesh is when you have an infrastructure near your application that will take care about handling the traffic, handling the communication between the microservices. So with Istio, you will have a better discovery, and I will show that to you, how Istio is better than the raw, pure Kubernetes. You will have resilience. I will show that to you as well. You will have authentication. You will have monitoring, and you will have tracing for free. So when you use Kubernetes, OpenShift, and Istio, you as a Java developer needs to focus only on the API. So before Istio, we needed a library to bring all those capabilities like discovery, load balancer, resilience, metrics, and tracing. But now with Istio, all those capabilities were moved to a sidecar container. And this sidecar container will intercept all the traffic, simple, using IP table rules. The IP table rules will be executed when the container starts. It will send all the traffic, all the inbound traffic, or even the outbound traffic to the sidecar container. And the side container will perform its magic that we will see, and then send the traffic to the application, performing a local communication inside the pod, again, using IP table rules. This sidecar container is implemented using Envoy. By the way, let me just open the page of Envoy here, Envoy proxy, and you can see that Envoy is an open source edge and service proxy designed for cloud-native applications, which means that it's very lightweight. It's fast. It was implemented in C, so it handles all the layer 7 traffic, most of them, HTTP1, HTTP2, gRPC. Otherwise, you can use just pure TCP, so it's very fast. You don't have the risk to say, I implemented Istio and now my application is slow. No, you don't have that problem. You will not have that problem. So just to have an idea of what is a sidecar container, it's just when you have something parallel to your main application. So what you gain when you use a service mesh? First of all, as I said, it's polyglot. You will have intelligent routing and load balancing, so I can perform better A/B tests. So for example, since I can intercept the traffic, I can place, for example, the user data on my HTTP header, and I can make the proxy read, oh, is this a VIP customer? So send it to the VIP version. For other users, just go to the regular version. Now, you can use that for smarter Canary release. You can release the version 2.0 and make it accessible just inside your company. Then you can change the rule and say, now only people inside Switzerland will see that version. Now worldwide can access that version. You can perform chaos testing. We'll see that. I'll talk more about that later. I'll talk more about resilience, circuit breakers, observability, and of course you can have a fleet-wide policy enforcement. So besides the sidecar itself, how Istio works? First, you need, when you install Istio, you will have a control plane composed by at least these 3 containers on the control plane side. The first one is the pilot. The pilot, just like a pilot that controls the airplane. The pilot will control the fleet of proxies by sending all the configuration to all proxies and in your service mesh. So every proxy will have the same configuration. In the other hand, the mixer works in the opposite way. It will receive information for the proxy. And what is this information for? This information can be used for quota. It can be used for telemetry, for data, for monitoring. It can be used for rate limiting. For example, I can write a rule that will say, my microservice can be accessed by 10 requests per second. If there are more than 10 requests per second, the proxy will deny that request. I can protect my application. And the only way to know how many requests the application is receiving is because the sidecar will report the number of requests to the mixer. And you have Citadel. Citadel is just like a certificate authority that will provide digital certificates to be used as a mutual TLS authentication between the microservices. So now in 2019, we have the polyglot microservice platform Circa. We don't need Eureka, as I said. We don't need Ribbon. We don't need the config server. We don't need Zoo or Hystrix. And we don't need to implement open tracing by hand. We can use Istio, and Istio will give us all those capacities. So let's see how that works for observability. When you install Istio, you will have installed also, for example, Grafana and Prometheus. I have it here installed in my Istio namespace. As you can see here, I have Grafana, I have Prometheus, but I've opened Grafana here, and I'm sending a bunch of requests. Let me just, you can see the number of requests increasing here. And the proxy is receiving that information and reporting those information to Prometheus and Grafana. So I can use Grafana to see the details of my service mesh. Let me see here. The workload. I can see all the details. And that was for free. I didn't do anything in my application. My application only provides a simple API that returns the name of the microservice. I have by the way, I have 3 microservices deployed. Okay, let me just show that to you. A microservice called customer, preference, and recommendation. A, B, and C. And they are just replying here. For recommendation, I have version 1 and a counter with the name of the container. Okay, so very, very simple to make us easy to not focus on the application itself, but focus on the capacities of Istio. Okay, so we have Grafana. We have also Kiali. By the way, Kiali, let me open the page to you. I like to show the page, the web page, so you can go there. Kiali is a project created by Red Hat. It will be part of Istio. And with Kiali, let me just open Kiali here, because Kiali is really nice. So let me open Kiali. And with Kiali, I can have a graphic visualization of my microservices. I can, for example, update it every 10 seconds, based on the statistics of the last minute. I can display the traffic. I can also show the request percentage, and I have the visualization of the sidecar container calling my application, and before calling the other application, the traffic is intercepted by the sidecar container. They are reporting to Jagger. Jagger is used for distributed tracing. So if I open distributed tracing here, Remember, my application does not have any open tracing API call. It's everything inside the sidecar container. So I can even see here customer, calling preference, calling recommendation, the number of requests. They are all reporting to the mixer. Remember, I can even call here and see all the invocations of the customer. I can open any one, and I even can see that before the Java Spring REST template call the preference, the traffic was intercepted by the sidecar. We can see how all the data from the sidecar container. So we can see here that we'll call preference and all the details. That's for free. Okay. Now that we saw that we can monitor, that we have observability for free, let's see how it works from the command line perspective. When we install Istio, we have a lot of custom resources definition. So when we do kubectl, let me just increase the font size here. kubectl get CRDs, which it means, let me log in as admin. Admin, password, it's hard, admin. I'll say project tutorial. kubectl get CRDs. I have a lot of custom resources definition. By the way, if I do a grep Istio, we can see them here. And the most important things of all those custom resources is, place it on your heads, virtual service and destination rule. We'll explore those objects when I'm handling traffic here, okay? So let's just recap how we deploy applications inside a Kubernetes cluster. Because for now, I just have the version 1 of my recommendation microservice, right? What I will do now is go to the recommendation source code to prove that's polyglot. This implementation here have a Node implementation, have Java with Camel, with Spring Boot, microprofile, Vertex, and when I arrive back to my home, I will, of course, use Quarkus. Of course, it's lightweight. But since I'm looking for something like lightweight before Quarkus, I will use Vertex, okay? And let me just change here from version 1 to version 2. So, yeah, let's change that to version 2. And now we can perform a Maven package. I can close here. Just a regular Maven package. Let me just... and I will perform now a Docker build using the tag example dash recommendation tag v2. Okay, oops. Docker build, and of course, where is my Docker file? So now I can do a Docker image grep recommendation and see that I have version 1. I have version 1 here that was built some 3 days ago, and I have version 2 that was built 5 seconds ago. Now that I have a Docker image, what I need? I need the Kubernetes deployment YAML file. So if I open this file here, just for you to take a look, deployment v2 YAML, you can see that it uses the image that I just built, example recommendation v2, plus it's everything related to v2 now. I give a name calling it recommendation v2, there are labels, it will run just one replica, ports, nothing special, right? But if I deploy that file, since it's not special, there will not be any containers inside it. So to inject a container inside that, together with my application, the sidecar container, I need to use istioctl. There is a parameter here called kube inject, right? Then I can provide the Kubernetes deployment v2 YAML file that will generate the output of a new file. Let me just redirect that to Istio recommendation with Istio YAML. Okay, this file here, just to show what has changed, I will show the difference between deployment v2 YAML and this recommendation with Istio file, gif merge. So what has changed? When we ran istioctl kube inject, it in fact modified my file to include the proxy. Plus, it has also some volumes declared. A volume to receive the configuration for the pilot, the volume to receive the certificate from Citadel, also some parameters related to the proxy. The proxy needs is the container that will run the IP table rules. So yeah, now Istio will be deployed together with our application. So let me perform a kubectl create -f recommendation with Istio. So now that I've ran that command, you will see here recommendation v2 is starting. By the way, let me just open this pod. You can see that the Istio init was already executed, and now my application has my pod has two containers. We have the Istio proxy and the recommendation proxy itself. I can even go here to the logs. There is the log of the container recommendation, and there is the log of the proxy itself. So we can see that the proxy is receiving requests. If we take a look here, we can see v1 and v2, because that's the default behavior of Kubernetes. It sends traffic to one pod and another pod, because we just have one single service. If we take a look here at services, recommendation, we have two pods receiving requests with no session affinity between them. So that's why I have v1 and v2 replying. Now we can start playing. For example, remember that I said that I can handle the traffic and I can control. So I can perform a blue-green deployment. Just to recap, what is a blue-green deployment? It's when you have a new version that you can deploy to one environment, and you just switch the key in the router to one version. If something goes wrong, you can just send the traffic back to the previous version. So now I have the version 1 and 2, but let me just send all the traffic to version 1. I have here some scripts to perform that to me. Scripts and blue-green deployment v2. I use two files here. Remember that I said keep those files, those custom resources in your mind. I have a destination rule and I have a virtual service. Let's take a look on them. So let me open the first one, the destination rule. The destination rule is used just to give a name for a subset. So I get every pod that has the version v1 and I call it version v1. I get every pod that has the label v2 and I call it version v2. Okay? Now I will apply the virtual service rule itself. The virtual service says that every time that I'm trying to access recommendation using the subset v2 that I've defined previously, send the traffic 100% to that version. So let's apply. Let's call the Bluegreen recommendation v2. And now, immediately, fast, zero downtime, everything's running on v2. If we take a look on Kiali, we will see that Kiali statistic will change over the time, and the number of requests on v2 will increase. It's being updated every 10 seconds. Yeah, so every 10 seconds it will change, and we will see that in the last minute the traffic is going to v2. Okay, now I want to do the opposite. I want to send every traffic to recommendation v1. Okay, immediately, again, zero downtime, the traffic is being redirected to v1. Okay, that's easy. I can clean the rules, and it returns to the default behavior of Kubernetes. Okay, what else? We can have a Canary deployment. Now things are starting to get more interesting. Canary deployment has an interesting name because of the British coal miners that they took canaries to the mine. Of course, on that time, there was a concern about if the canary would die or not. So, and on that time, there was the canary resuscitator, where they just locked the door and opened a fresh air cylinder, so the canary would at least not die. But the concept for software is that you place your canary version on production, and then you start sending traffic, and your canary version should survive. And then you can start increasing the number of requests on the canary version until it gets 100% of traffic. And again, with Kubernetes, you have a default behavior of sending the traffic to one version and to another. So, but with Istio, you can control the traffic because you have the proxy on front of it. So I can say to Canary, to Istio, Canary, let's perform a mix of 90-10. So I have two subsets declared, one with 90 and another with 10. Once that I apply those configuration files, we'll see v1 most of the time, and sometimes you can get a v2. Okay? Let's change the mix to 75-25. Now we have v2 being part of this pool of microservices more often in a ratio of 3:1. And I can have something even more special. I can just send the traffic based on the user agents. So let me show to you how that looks. If I open this virtual service, you will see that if my HTTP header has a user agent with the regex string calling Safari, send the route to version 2. Otherwise, call version 1. So remember that I said that I can control that you can send a VIP customer to see the VIP version. You can use the same thing to do this. So based on user agents, okay? Now I can only see v1, but my browser has v2. So let me open this URL here. No matter how many times I refresh the page, you can see I'm refreshing, I will always get v2. So let me open here, inspect, network, refresh, and I can see that my request user agent has Safari. So that's why I always see v2. Okay, and let's remove all the rules at this moment. Now the default behavior. Okay, let's continue and see what else we can do with Istio. We can perform dark launches. Dark launch was became very famous with Facebook Messenger, where Facebook Messenger was placed on production 1 year before we seen it. So we can use Istio to perform dark launches for us as well. We can place something on production. We can mirror requests to the version v2, but the user will not see the requests returning from v2. For the user, it thinks that he's always accessing v1. So let's perform a dark launch here. Dark launch. For me, as a user, I see the output only of v1. But if I go to the console and open the logs of the pod v2, the logs, I can see that v2 is also receiving requests. Can perform dark launches, mirror the request to the version 2. Okay. What else we can do with Istio? Istio is so nice. We can perform the part of service resilience that's really interesting because remember that I said that our microservice will fail. So we can perform retry. Let's make a microservice fail here. I will run a script that will cause one microservice to fail. Come on. Oh, retry, fail. Let me just clean the scripts. And scripts, retry, fail. Yeah, I can even write a rule to make the microservice to perform badly. Okay, now you can see that's failing now. What I can do, I can write a rule that will perform a retry. I have 2 copies. Let me see here. Yeah, I have 2 replicas of v2 now. One v2 is v1 is okay, one v2 is okay, and the other v2 is failing. So we have always that. v1, v2 fail, v1, v2 fail. Now I will write a rule to retry. When Istio tries to access the other endpoint and it receives an HTTP error, it will just retry, and then it will land in the v2 that's working. And now we can see here, there is an error on Kiali saying that v2 is failing. We can see the amount of requests that are failing. But for the user, it's everything okay, everything's fine. Okay. We can also have, for resilience, we can have pull ejection. Pull ejection is a little bit more different because the pull ejection allows you to access the failing instance, but when it sees that there is a failure, it ejects from the pool and avoids it for some seconds. Then it might try it later and see if it's working again. So let's wait. We'll see that it will try again the v2. It tried, it's not working again, so it ejects from the pool. And of course you can have a great resilience if you write a circuit breaker, a pull ejection, and a retry policy. That would be great. You can have chaos testing. So how my microservice would behave if one microservice starts to fail? I don't know, it needs to start failing. No, you can write a rule that makes my microservice fail. So let's make it give 500, the error 500, 50% of the time. I can write a rule for that. Now, 50% of the time, my microservice will fail. Or I can make it slow. I can write a rule that will make v2 become slow. Now I can see how my microservice behave if it's low. Okay. Of course, it's we can have access control policy. For example, here customer can access preference, can access recommendation, but recommendation cannot access back preference. That's not allowed. Preference cannot access customer. Recommendation cannot access customer. I can control that with Istio. Most of the time, communication is inside microservices are inbound and internal. But what happens if a hacker places a malicious code on my application that sends sensitive data outside of the cluster? Istio blocks all the outside traffic by default. It's blocked. So you need to write, in the case of an exception, you need really to access an external resource, then you need to write a rule that allows you to access the external resource. Of course, there are many things in Istio that I'm not able to cover in this 40-50 minute session. So I suggest to you at least 3 ways to start learning Istio now. Go to Red Hat Developers, get the Istio book, okay, for free. Or you can go to this URL, learn.openshift.com/servicemesh. And this is really cool because that will give you a virtual cluster with an interactive console that with Istio installed. You can install the microservices. You can run a terminal here. Now it's just providing, but it's a Linux terminal, right, with a web console, and you can just go. It's lessons that you can just execute the commands here, and that's a perfect way to start without need to install anything on your machine. Or you can, if you want to install Istio on your machine, you can go to this URL Istio tutorial. In this link, you will see everything that I used. I used Minishift, which is just like Minikube, that allows me to have a local cluster. If you open here the documentation in HTML, you will see everything. You can perform and learn how to do observability, traffic control, service resilience, chaos testing, policy, security, and even advanced Istio tutorial with Kiali, virtualization, zero-time migration, dark launches, and everything else. Plus, you can have also access to the source code. As I said, you can even see how it behaves using a .NET microservice. And again, just keep the link. Next week there will be Quarkus here. Woohoo! Okay, this is the end of our session. This is the end of Vox at Zurich. I hope that you have enjoyed the day, and we are open to questions. Questions? Oh, okay, we have two questions there.
You showed on one slide that I want config server. Why?
The great question. To be honest, I don't remember why I placed that. Why I didn't place config. I said that I don't need config server anymore here. Yeah, I would try to recap and publish on my Twitter account. So that's also an excuse to say, if you are not already following me on Twitter, you can just go to my account and follow. Let me just, yes, here. That's just an excuse for that. Any other questions?
Specifically about the retry, when I do anything else than a get, so something non-item token, does Istio help me in any way there?
Do you mind to re-explain the question, please?
If I do post,
okay.
it can be
Yeah, that's a great question. So the question is, what about the post? I did a get. If it was a post, would the retry send all the parameters, all the data? Yes. Oh, we are just on the time. So thank you for the questions. Thank you for your presence. And I hope to be here in other opportunities. Thank you.